Topic 3.1, we're going to go over measures of central tendency. Excuse me, the mode, median, and mean. So this might be some stuff that you've been familiar with before today for sure. You may see some new symbols and we'll talk about what those mean. So mode is the value that occurs most frequently in a data set. Sometimes your mode, you could have more than one or no mode. Median is the middle data value or the average of the two middle data values when the data are in ascending order, so from least to greatest. To find the actual position, what you can do is take however many numbers there are in the data set, add one and then divide it by 2, and that can tell you where that position is if you want to, and you're not just, if you're working with a small set of numbers, you usually can work your way from outside in, but sometimes we're going to be working with a lot of data values. So to find that position, you can do it this way, which we'll talk about when we see it. The mean is the sum of all data values divided by the number of data values. If you think average, that's what your mean is. So your sample mean, there's two different kinds, so be aware of a little bit of a difference here. This is read as X bar. And so that's going to be like the mean of the sample that you took. This little symbol right here is summation. So the sum of your X's divided by however many values were in your data set. And then here is your population mean. So this means like every single person, if you were able to survey, for instance, every single person and find their mean. Now this is going to be given, so we do not have to calculate that. So the rest of this, other than a couple new symbols, should look pretty familiar to you. It says find the mean or the mode, median, and mean of the following data. I can tell that the two data values, there's a number that repeats twice, and that's the number 3. When we do the median, we need to put these in order from least to greatest. So do that first, least to greatest. So let's say we have, and I'll just do it over here to the right, 3, 3, 7, and 8. And so your median would be your middle number. If you have an even amount of numbers, you might share 2 middle numbers like this. So you would be taking 3 plus 7 and then dividing it by 2 to find the mean between those two numbers, the average. So 3 plus 7 divided by 2 is 5. So the median for this data set, this set of numbers would be 5. Our mean, we're going to add all of that up. So you're going to put your total over however many numbers there are in the data set, which there's 4 numbers. So when we add all those together, 3 plus 3 plus 7 plus 8, I'm adding it in my calculator now, is 21 divided by 4. So 21 divided by 4 is 5.25. So that would be the mean of this set of numbers. So if you were to do what we were talking about to find the position of the middle value, that n plus 1 divided by 2, it would look like in this case 4 plus 1 divided by 2. 4 plus 1 is 5. And so when you take 5 divided by 2, you get 2.5. So you're going to be right there in the middle between 2 digits. You're going to be in the middle between 2 and 3. That is what happens when you're working with an even set of numbers. Data set has an even set of numbers. So because when we reduce that to 2.5, that means it's between 2 and 3, the second and the third digit. So that is a way to do it instead of using your fingers, but it works just as good with that little set of number that way. Okay, let's do another one. It has a few more digits in it. I actually am generally in the habit of putting it in order from least to greatest to start with. I don't know why I didn't on example one, maybe just overlooking it because it was a small amount of numbers. So I'm going to do that first. Oh, there's 2 5s. And then 8 and 9 and 9. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So I do have 8 digits. That way I don't forget. So my mode is the number that repeats or repeats the most often. And we do have 2 different modes in this case. 5 repeats twice, and so does 9. So we would say the mode would be 5 and the number 9, both. Now, if we would have had another 9, the mode would only be 9. If there were 3 9s and 2 5s, that would be, it's not just a number that repeats. Sometimes there are numbers that repeat, but it's the one that repeats the most. Okay, your median, if there's 8 digits, we are going to be using the 4th and the 5th digit. So we would, so that's another even set of digits. We'd have 8 plus 1 divided by 2. And so that would be 9. So that'd be 4.5. So that means between 4 and 5, the 4th and 5th digit, if you did it that way. Or you could simply use your fingers to work your way in. So we'd be taking 5 plus 6 divided by 2, which is 5.5. And then our mean, we'll be adding all those digits up on the top in that set of numbers, and we're going to divide by 8 because there's 8 of them. So 2 plus 3 plus 5 plus 5, 6, 8, 9, and 9 is the number 47. So 47 divided by 8 is 5.875. So if they don't give you rounding instructions, you would show all 3 of those digits at the end, but also pay attention in case they do have rounding instructions and do follow those instructions. Let's turn the page. Working on another one. Find the mode, median, mean of the following data values. So this one is already in order from least to greatest, which is wonderful. This one does not have a repeating digit. So this one would have, we would say does not exist because there's no repeating number, no number that repeats. Your median would be your middle number. So there's 1, 2, 3, 4, 5, 6, 7 digits. So if we took 7 plus 1 and divided it by 2, that would be 4. So the 4th number would be the middle number if you're doing it the way we learned on the other page. Other than you could use your fingers and work your way in to find that the middle number is 10, assuming and knowing that that order, that set of numbers is in order from least to greatest. My mean is the total of those numbers divided by 7 because there's 7 digits. Okay, so let's go do that. 5, 8, 9, 10, 13, 15, and 18 gives me 78. So 78 divided by 7 is 11 points. And this one, the decimal doesn't end. So this would probably be a good example of you would be given rounding instructions. So let's say we're rounding to the nearest hundredth. I'm just going to make my instruction. So we would say that that would be 11.14. Okay, so let's apply this now in a course entitled Experimental Psychology. Students train white rats to do various tasks based on a performance reward theory. One event is the hurdles. So you have these times in seconds for 7 rats. And I guess you don't have to count how many data values there are to run the hurdles. It says compute the mean, median, and the mode. So my mode, I'll just go in order actually of what we were answering before. My mode we talked about first, and it looks like 3.3 repeats. You know, before we go further, let's go ahead and put it in order like I usually do. So 1.8 looks like it's the smallest. Then we have a 2.3, then a 2.9. Then we have a 2. Actually, we have a 2.8, then a 2.9. There we go. That in order. And then we have a 3.3 and another 3.3 and a 5.2. I'll put little commas between these so that we can see them different. All right, so we do have 7 digits there. You can kind of see, especially when you reorganize them, you can see the repeating numbers a little bit easier sometimes when they're side by side. My median is the middle number, so there's 7 numbers, so that would be the 4th digit would be the middle number. We did that one kind of above, so my median is 2.9. And my mean, we're going to find the total and divide it by 7 because there were 7 data values. They tested 7 rats. And so when you add all that together, you're going to get 21.6. And so 21.6 divided by 7 is this 3.085714, on and on and on and on. And so again, let's say that they tell us just to practice, because we do round sometimes to 2 digits and 4 digits a lot. So let's round to 4 digits, which is the 10,000th place. So we would keep the 7 the same, and we would call that 3.0857. Another event is the ladder climb. Times in seconds for 8 rats to do the ladder climb were this. So we're doing 8 rats now. And if you kind of look at this set of values, you notice this number is quite bigger than all the other 7 digits. We call this an outlier. So sometimes outliers kind of skew some of these measures of central tendency, especially the mean. And we can see how it can affect it as we work on that. So let's go ahead and put them in order from least to greatest. So we have 5.1, 5.5, 6.6, 6.6, 6.9, 7.7, 7.9, and 41.9. Way big difference between all the other numbers that were between 5 and almost 8. Maybe this guy took a break when he was working on his ladder climb. All right, so the mode is the number that repeats the most. And so that would be, looks like 6.6 is the only one that does repeat. So 6.6. Our median, if this is an even amount of numbers, that means our 4th and 5th number are going to be, in this case, our middle digits. So we have to find the average of it. So 6.6 plus 6.9 divided by 2 gives you 6.75. And then your median, or not median, I just did median. Your mean, we would be dividing by 8 because there's 8 total data values, and we're going to add all those up, and I've already done that before we got started today, so that's going to add up to 88.2. When we divide by 8, you're going to get 11.025. And so you can kind of see how your mode and your median were pretty close, but because of this big value, it really makes a big difference between the mean and those other two measures of central tendency. You know, if you kind of go back to the other example where we only had 7 numbers, but these mean, median, and modes were all really pretty close. They're really close to 3. All 3 of them are. But these two are in the 6s, and then it jumps on up to 11. So that's what we call an outlier, and it can skew some results with with our mean in this case. Example 5, how large is a wolf pack? The following information is from random sample of winter wolf packs in regions of Alaska, Minnesota, Michigan, Canada, and Finland. Winter pack size are below. So we have all of these data values. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. So there'd be 18 digits in the set of data. Okay, so we're going to compute our mean, median, and mode again. You would really want to put it in order from least to greatest. So I'm going to do that. So we have 2, 2, and there's another 2. Then we have 3, 3. Then we have 3 4s, 1, 2, 3, 1, 2, 3. And then we have a 5. I think we only have 1 5. We don't have a 6, but we have some 7s. It's like we have 4 of those maybe. 1, 2, 3, 4. We have 2 8s. We have a 10, a 13, and a 15. Okay, so our mode. Now remember, I know 2 repeats, 3 repeats, 4 repeats, but it looks like 7 repeats the most. There's 4 7s, only 3 4s, 2 3s, and 3 2s. So 7 would be the mode on this one. So it's not just because it repeats, it's the one that repeats the most. I guess we also had some 8s that repeated that I skipped out on. Our median. So I said that there are 18 digits, so that's an even amount of numbers. So if we take 18 plus 1 and divide that by 2, that would be 9.5. So that means the 9th and the 10th digit. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So you should have 1, 2, 3, 4, 5, 6, 7, 8. You should have 8 on this side as well. 1, 2, 3, 4, 5, 6, 7, 8. Or you could have used your finger and worked your way towards the center if you wish. Sometimes we're getting to where we have a lot of data values, so kind of need to understand that a little bit, or at least it does help sometimes. So we're going to find the average of that. 5 plus 7 is 12, divided by 2 is 6. So my median is the number 6. Probably could have been able to tell that just thinking about the number line. And then your mean, you're going to add all those digits together and we're going to divide by 18. So I haven't done this one yet, so I'm going to go ahead and do it. So 2s, and then we had some 3s. Then we had some 4s. And then 5. 7s, 8s, a 10. So that's 111. Hopefully I did it right. I am not going to be super diligent and go check it. Hopefully you did. If I get it wrong, I'll fix it on my written notes. Hopefully I did not. So you're going to be repeating that 6 digit for a long time. But if we were going to go to 4 digits like we do on a lot of things, you may want to write 5 of them down. So we would say 6.1667 because we would want to round that up. So those data values were all pretty close to the same. There wasn't like a big number that jumped away from all these other numbers. So you'll notice that your mode, median, and mean are all pretty close. Your 6s and 7s. So we're going to talk about trimming the mean because of outliers. So, looking back at this problem, maybe to make a more accurate mean, we could trim some outliers out. And so we're going to learn about that next. So trimmed mean, the mean of the data values left after trimming a specified percentage of the smallest and largest data values from the data set. That's what we're doing. That would be the mean of the data after we trim the biggest and the smallest values. If this is used to eliminate extreme data values or those outliers that we talked about, the data must be ordered from smallest to largest, just like we do when we're working with our median. It helps us. So we're going to do two things. We're going to compute a 5% trim mean. So that means you're going to delete 5% off the bottom and the top. And so what we would do is, let's say you have 100 values, 100 digits that you're looking at. You would take that times 0.05, and that would tell you that you're going to trim 5 numbers from the bottom and 5 numbers from the top. So you really trim a total of 10 numbers. So when you get this digit, that's not the total amount that you trim. It's how many you trim off the bottom and the top, the higher numbers. And then you'll calculate the mean from the remaining 90 values. If we do a 10%, it's literally the same thing, except for we're multiplying times 0.10. So we would trim 10 from the bottom and 10 from the top, eliminating 20 numbers from this set of numbers. So for instance, example 6, we're going to calculate the actual mean, a 5% trim mean, and a 10% trim mean. So these numbers are in order from least to greatest when they're set up like that, which is wonderful when they do that. So we're going to go ahead and calculate the actual mean. I haven't done this one yet, so I can't tell you the sum of those yet. But we know that there's 20 gymnastics classes. I've usually just jumped right to calculating the 5% and 10%. So I'm going to pause this and then come back to it. Okay, so when you add all those digits together, I got 729, and then we would divide it by 20. And you would get 36.45. So that would be the actual mean of all 20 numbers. If we did a 5% trimmed mean, what that means is you're going to take there's 20 data values, 20 digits. We're going to multiply it times 0.5, and you get the number 1. So this means we're going to remove one number from the top. I probably should have wrote one number from the top and the bottom. So 2 total numbers get removed. So like this. And then you would just add all those digits together. So one thing I do, especially since I've already figured that, is I would subtract 8 and 85 to kind of make a shortcut. 729. I have a syntax error because I hit minus twice. And that would be 636. So we take 636, and now if you trimmed the top one from the top and the bottom, there's only 18 digits, right? So you'd need to subtract 2 from the total number that you did have. And so once you get that, you'll divide by 18 and you'll get 35 point, and we'll go ahead and round to 4 digits. So we would just stop at 3 because the 3 is repeating forever and ever. And so we would keep 3 the same, making that 35.3333. It does tell us to find the median of both. So I better go back and do that too. Or the median of each. So remember, if we take 20 plus 1 and divide it by 2, you'd get 21 over 2. So 21 divided by 2 is 10.5. So that means the 10th and the 11th number before we had eliminated them. But you also could think these two digits that were on the ends, those two would be right there in the middle of the set of numbers. So your median would be 31 plus 34 divided by 2, which gives you 32.5. So this is the actual mean before you trimmed any off the top and the bottom. And hopefully you'll notice your median, those numbers are always going to stay in the middle if we're eliminate the same amount off the top and bottom, no matter what. Because even if we went to 18, we talked about 18 digits and we were going to find the median. 18 plus 1 is 19 divided by 2 or over 1. That would be the 9th and the 10th digit. Well, since you've eliminated these two, it's still the middle two numbers. So your median would be the same. Still the same digits. 10% trimmed mean. Times 0.10. So you're thinking about all 20 still when you pretending we didn't do the 5%. So that would be 2 digits off the top and the bottom. So this one and this one. So we would go find, so remove, I'll write this down, remove 2 from the top and bottom of the list. Okay, so you remove 4 total digits here. We removed 2 total digits in the 5% mean. So whenever you go add these together, or you could simply, what did we have here? 636 was the total of when there were 18 digits. Now when we have 16 digits, we could subtract 14 and 85 and get 537. And so we will divide that by 16, and that would be, it does end in 4 digits, so we don't have to round, 33.5625. So one thing, again, the median would still be the same, 2 middle numbers, so my median remains the same. 32.5. So one thing I didn't really do is this is where you're going to see your X bar, because that is different than like the population mean. Whenever you saw that symbol on that page before, let's go back to it just real quick, because I do like to talk about symbolism, and I think I kind of skipped over it. Your population mean would be the mean over the entire, and this little symbol is called mu. And I will refer to it a little bit, but we're not working with it yet. Really, all we've done so far is work with an X bar mean. And so it probably would benefit me to at least, or benefits to talk about that with you guys. This was a sample. You know, it said a sample, so we know that we're working with an X bar type problem. So in WebAssign, I'm just telling you that so you'll know where the symbol comes from. The X bar, it'll say X bar, and then it would say equals 36.45. So that's just a way of showing that you're answering the mean. If you see that, this one would say X bar equals 35.3333. You would just enter the digit that you found, but you will see that X bar pop up in this assignment a little bit in WebAssign. So I'm going to go ahead and write it on my notes to make it look just a little bit more proper. Because while we know all that about mean, median, and mode, maybe that symbol just looks a little unfamiliar to us. And we have one more example for this 3.1 content. It says, how expensive is Maui? If you want a vacation rental condominium up to 4 people, visit a Maui tourism website. The Maui News gave the following costs in dollars per day for a random sample located throughout the island. And so it doesn't look like this list is in order from least to greatest. So that's kind of a bummer. So we need to do that. And I've actually already done it before. So I'm just going to copy it down so I don't miss anything on accident, and my notes will be nice and clean for you. But really, I would have just taken my time to go list these digits, and I still did it where I separated it in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits in each row, because I think it helps a little bit when we're trimming the mean. Big differences between some of these, right? $40 or $500. Big difference. That's where those outliers really start to come into play. So it doesn't really give me instructions, but I'm gonna do both the 5% and the 10%, since that's what we just learned. So I'm gonna do a 5% trimmed mean. I'm not gonna do the actual mean of the data set as it is. I'm just gonna do 5% trim mean to start with. So there are 20 numbers again. So remember, the first thing you would do is take 20 times the 5%, which means you're going to remove one digit from the top and the bottom. So we're going to X out the first and the last digit. And then we're going to go find the mean, which is your X bar. So I'll start writing it better on this one as an X bar. When you add all those together, pull out your calculator and you can do it, but I've already done the addition for you. That'd be 2183. And then there's now 18 digits that we added together. So we would divide by 18, and it looks like we're going to get 121 or 121. And it looks like we get a 7 that repeats. So we'd want to round up that 4th digit. If we were to go find the median, that would still be these 2 digits right here. You could take that 18 plus 1 divided by 2 if you wanted, or you could work your way in, and you'll just notice you'll get to those same 2 digits. I think that's why I like the rows written too. It kind of helps with all of that. So 65 plus 68 divided by 2 is going to be 66.5. Big difference between the sample mean and your median even. Let's see if trimming 10% off kind of helps these 2 numbers get a little bit closer together. So if we were to, I guess I already know it's going to be trimming 2 off the top and the bottom. I was just jumping to it, but we would take 20 times that 10%, which means we're going to remove 2 digits from the top and the bottom. So we now have 2 digits from the top and bottom X'd out, and we're going to go find our mean. So our X bar, the sample, that was a sample of condos in that area. Probably wasn't every condo. And when we totaled the 16 digits we have left, we had 1763, and we would divide by 16, which would give me 110.1875 when we round. Our median is still the same, doesn't change. Still have the same 2 middle numbers. So we're getting a little bit closer. I mean, it's $11 difference or so, but when you're trimming those highs and lows, you kind of get closer to those middle numbers. And really, we only do a 5 and a 10% trim mean.